Bismillahirrahmanirrahim. Real and apparent weight and weightlessness in satellites. Generally, the weight of an object is measured by a spring balance. The force exerted by the object on the scale is equal to the pull due to the gravity on the weight on the object. That is the weight of the object. This is not always true, as will be explained in the little later. So we call the reading of the scale as the apparent weight. To illustrate this point, let us consider the apparent weight of an object of mass m suspended by a string and spring balance in a lift as shown in figure. This is a spring balance, this is a string, and this whole combination of mass and the weight balance or spring balance is suspended from the roof of the lift or ceiling of the lift. And that lift is at rest initially. In this state of rest, you can see that the tension in the string, tension is the force which is acting in the string in the upward direction, and weight is the force which is acting downward, that is actually the pull of the earth for the mass. If the body is at rest, the net force will be equal to 0, as tension is in the upward direction and weight is in the downward direction, and the body is at rest. It means there is no acceleration, as acceleration is equal to 0. So net force is equal to 0. And net force of any object, net force acting on any object can be given by the formula F is equal to ma. So F is equal to 0 as A is equal to 0. So net force is equal to 0. It means that tension force and the weight force balances each other and body is at rest and there is no acceleration. For example, if the tension is in the upward direction is of value 6 Newton and the weight is of value 6 Newton, the net force will be equal to 0, and so acceleration will be equal to 0. But when the lift is moving upwards with an acceleration A, then what happens? In this situation, tension in upward direction and weight in the downward direction does not balance, and there will be some positive value. As body is moving upward direction, it means that tension value, force of tension is more as compared to the force of weight, as the mass small m is moving in upward direction. It means that ceiling is moving upward direction, and ultimately that ceiling applies a tension force on the mass which is greater than the weight force. So tension will be equal to W. If we take W towards the right, then tension will be equal to weight plus MA or net force. It means apparent weight of the body, which was initially equal to tension, now tension is increased in the string by MA value. It means if the tension is of value 10 Newton and weight is of value 6 Newton in the downward direction, the net value of 4 Newton is accelerating the mass. We know that net force of 4 Newton will act on the mass and it is accelerating in the upward direction with some acceleration A. If we take this 6 value towards the right, then it means that initial weight of the body is added with some another value of ma, and it will be equal to tension in the string. So tension in the string is equal to 6 plus ma. It means tension is increased as compared to 6. How many times? It is increased with a value of ma. And tension defines the spring weight or spring reading. If tension increases, then spring reading will increase, our apparent weight will increase. It means when the body is moving in upward direction, then the apparent weight of the mass looks more, or it increases. So apparent weight is increased. And if the lift is moving in downward direction, then what happens? Suppose that the lift and hence the object is moving downwards with an acceleration a, then we have weight more than the tension. It means if the weight force is more than the tension force or the upward pull force, then ultimately the body is moving, the mass is moving in downward direction. And that mass is moving with an acceleration of value a, and the net force is equal to ma. If we see the tension over here, then tension in the string is decreased from the weight value, initial value of W, with a negative sign or by decreasing a value of Ma. It means weight is decreased with a negative value of Ma. I mean, if initially the weight was of 6 Newton and the tension in the string is decreased as the ceiling is moving downward, and when the ceiling moves suddenly in the downward direction, then the tension in the rope or the string will decrease, and if let it decreases to a value 2, then weight was initially 6, tension is now with a value 2, the net force of 4 Newton will accelerate the mass in the downward direction as weight is more and tension is less. It means that tension is decreased to a value 2 as weight was initially 6, but that weight, some part of the weight is decreased because of downward acceleration. Let us now consider that the lift is falling freely under the gravity, then acceleration becomes equal to acceleration due to gravity, and hence the net tension in the downward motion will be equal to 0 as acceleration becomes equal to g, and initial weight is equal to mg, so mg minus mg is equal to 0. So the freely falling body will show the apparent weight of value 0. There will be no apparent weight of the free falling body or no tension in the string, or the apparent weight of the spring balance will be equal to 0. Conclusion. So it is understood from these considerations or these examples given in the above slides that apparent weight of the object is not equal to its true weight in an accelerating system. It is equal and opposite to the force required to stop it from falling in that frame of reference. Now, we see the weightlessness in satellite. Astronauts feel weightlessness in a spaceship which is moving with a uniform circular motion about the planet, say Earth. And why the astronaut feel weightlessness? Because there is no apparent weight of the astronaut in the free-falling satellite. This can be proved by a mathematical relationship and by common sense. First of all, we see the mathematical relationship. If this is a spaceship shown by the red boundaries and astronaut is shown by this small black circle, then the overall system is having a mass of capital M is a mass of satellite and small m is the mass of astronaut. So total weight or the total pull of the earths to the whole system will be equal to capital Mg plus small mg. Pull of the earth due to the mass of satellite and pull of the earth due to the mass of man or astronaut. So total force of gravity or the weight of the whole system will be equal to capital Mg plus small mg. And this weight force will be acting or will be providing a centripetal force to this system, satellite and astronaut whole system. And we know that centripetal force is given by the formula total mass V square over R. mv square over R, total mass into V square over R is actually centripetal force. If we take G common from these two terms, then inside the bracket there will be capital M plus small m, and this will be cancelled by this capital M plus small m. Now, dividing with the capital M plus small m, we get the result V square is equal to G, and we take this small r to the left side in the numerator by cross multiplication, and we get V square is equal to GR. Now consider the man only, or the black circle only, with a mass small m. We can see that this small m or mass in the satellite have a weight of small mg, and there will be a reaction force from the surface of the satellite equal to capital R. If we want to calculate the net force on the astronaut, that will be equal to mg minus reaction force, and that net weight on the astronaut will be equal to mv square over r, or it will be net weight and net force of attraction by the earth will be providing the centripetal force. And as we know that v square is equal to gr, so we put the value of gr and r will be cancelled by r, so it will be equal to mg, and by moving mg over here and r to the right side, r will become equal to 0. It means reaction force will be equal to 0. If the reaction force is 0, then action force will always be equal to 0. It means weight of the man or astronaut is equal to 0. So freely falling satellite and the man inside the freely falling satellite will feel the state of weightlessness. And secondly, the common sense is that if a man or astronaut is falling freely, then according to the previous discussion, a freely falling system under the gravity feels no weight or weight. He feels the state of weightlessness. Thank you for watching the video lecture. Please visit the website www.kencolly.com and subscribe our channel. Thank you.